Yes, yes, friend. Here is a question. An aircraft execute horizontal loop of radius 1 kilometer with the speed of 900 kilometer per hour. Calculate its centripetal acceleration and compare it with acceleration to gravity. So solution is simple. Actually, A equal to V square by R. So, but here V 900 kilometer per hour. Convert into meter per second. 900 into 1000 upon 1300. हाँ भाई और जा तो it comes out 250 meter per second. Radius are 1 kilometer. How many meter? 1000 meter. So A equal to 250 square upon 1000. This square 62500 upon 1000. So it comes out how much? Hey boy, 62500 upon 1000 क्या लेने? 62.5 meter per second square. Listen me carefully. There are 30123. Put the decimal after 1, 2, 3 digit. Got me? ये simple तरीका है. Decimal अगर था don't keep on cutting and cutting. So the radial acceleration here comes out to 62.5 meter per second square, and hence AR upon G 62.5 upon, if I take G as 10, it comes out 6.25. This is a ratio. That means centripetal acceleration is 6.2 times more than. So this was simply for a practice question. Direction to center होगी. Now there is another question here. Also, you may feel here little difficulty, little difficult. क्या है? In XY plane, particle move with constant speed v on circular path of radius r. Of radius r. Right? Write the expression for its acceleration vector a. Vector a लिखना है आपको. When it is at point r and theta of the circle. XY plane. Here you can show like this. This is the position here. This is position vector r and this angle theta. So you know. When velocity is v here, magnitude तो v है ही, तो क्या what is the acceleration vector form में? Actually this is x-axis, y-axis. We can take I cap unit vector, j cap unit vector. If I take this, suppose AR is this, तो AR जो है magnitude v square by r है. But we have to write in vector form. So we can take component of these two vector, this one and this one. This positive I is kept in this direction, positive I this direction. So here these are two vectors. So vector A can be also this angle theta. So component of A along this direction. A cos theta. In case it will be minus v square by r cos theta I cap. Let me write in next line here. Vector A is equal to minus v square by r cos theta I cap minus j cap positive this direction. It is this downward. So minus v square by r sin theta j cap. So you can be asked like this. What is the, sorry, capital R here, capital R. So there are many questions based on centripetal acceleration in textbook also, but remember that centripetal acceleration is a case of uniform circular motion, and has direction towards center along radius. Now I come back to some questions of NCERT book which create trouble for students in this video. What are those? In our NCERT book, there are objective questions based on acceleration. So one question this. There is a VT graph like this. Time and V, velocity. V. The graph is like this. For this VT graph, which of these are correct and which are wrong? xt2 is equal to xt1 plus vt1 into t2 minus t1 plus half a into t2 minus t1 whole square. So you are asked, is this equation is represented this graph? xt2 सेकंड इक्वेशन मोशन है किसकी? Of uniformly accelerated motion. Here acceleration constant. It is VT graph. From VT graph you can calculate acceleration, and if VT graph is a straight line making angle theta with time axis, then acceleration constant, and this graph is never a straight line, keep on changing. So this equation is not true for this. This equation is true only for uniformly accelerated motion. Second equation they are writing Vt2 equal to Vt1 plus A into T2 minus T1. This equation is also not true because it is again for this graph, or we cannot derive this equation from this graph because it is for constantly accelerated motion, and here acceleration keep on changing. Here actually this, here it is this, and here 0. ठीक है भाई? The second equation, V average, velocity average is equal to xt2 minus xt1 upon t2 minus t1. It is true because this is definition of average velocity. As A average is equal to Vt2 minus Vt1 upon T2 minus T1. This is also true. And then they write here xt2 minus xt1 is equal to V average into T2 minus T1 plus half A average T2 minus T1 whole square. This is also not true because this type of equation is true only for constant acceleration, not for average. Then further they say xt2 minus xt1 equal to area under vt ग्राफ, एरिया अंडर ग्राफ कह दो, ये ट्रू है. We know area under vt graph is equal to acceleration. So this is true. Now there is one more question here in this book, that is from NCERT. What is that? तो मुझे याद है वो कहते हैं, सुनो मैं ऐसे लिख रहा हूं कि which of the following equation is true for any arbitrary motion. For any arbitrary motion, there are some equations. Are these true for arbitrary? Arbitrary means मनमानी कोई भी, whatsoever the motion may be. Is this equation true for all those motions? है भाई, पहला तो ये है vt1 vt2 is equal to vector v is equal to vt1 plus a into t2 minus t1. What do you think? Will it be true for every arbitrary motion? No, it is true only for linearly accelerated motion, constant acceleration. Similarly to v average is equal to xt2 minus x, या ऐसे लिखो rt2 minus rt1 upon t2 minus t1. So what do you think about this? This is true for any motion because average velocity is the change in position per time. So it is simply telling that thing. Number 3, xt2 minus xt1, the same thing, vt1 plus vt1 into t2 minus t1 plus half a into t2 minus t1. Again, this is not true for any order, it is only uniformly accelerated motion. So like this question are there. There is one question in our NCERT book also, a body is moving on circular path. A body moving on circular path. It is not said to be what is there, but simply given moving on circular path. So is it true that acceleration of motion must be along radius? Number 1, acceleration of motion must be along radius towards center. और along radius कहते हैं towards center का दो. So is it true? If body moves on circular path, then acceleration of this motion must be towards center along radius. Is that must be? Must be means है भाई, क्या always नहीं? It is not true because if there is only it is true when body moves with constant speed. Here it is not mentioned that body moves with constant. It is they have simply said if body moves on circular path, then acceleration must be towards center. That thing is true only for uniform motion. यानी कि with constant speed चलेगी. Now there is one more question. In one dimensional motion, in one dimensional motion, the if acceleration is positive, then body must be speeding up. Question is that if acceleration of motion in one dimension is positive, acceleration is positive, then body must be speeding up. Body must be speeding up. What do you say about this thing now? If acceleration positive, then body must be speeding up. Must be. Here the word is must be used. Must be. Actually, acceleration positive, negative. Acceleration is vector quantity. If we fix direction left to right positive, so right to left negative. Or if we fix direction upward positive, downward negative. Upward positive, downward negative. And from the ground we throw a ball up. We have taken upward direction positive, downward negative. So when ball is coming down, so acceleration is downward and the G downward है and downward direction negative है, but velocity is increasing. Even negative direction. है भाई, positive का होगा acceleration. If I fix, listen here. If I fix upward direction negative and downward positive, ठीक है भाई, ball is thrown vertically up, acceleration G downward positive, G greater than G positive, but speed is decreasing. तो sign of negative or positive sign of acceleration depend upon our sign convention. So it is not always true that if speed is acceleration is positive, then body must be speeding up. Like I have fixed here direction upward direction negative, downward positive. And when we throw the ball upward, acceleration will be downward positive, but velocity increases. So these are certain problems based on motion, and this way you can try all the things from different books. You can message me, dear subscriber, if you have any problem, then you can message me. I can send you the solution in a message. Thank you.